नमस्कार बच्चों। मेरा नाम धन्या और हम लोग ग्रेड 11 केमिस्ट्री का थर्ड लेसन सीख रहे हैं जिसका नाम है इलेक्ट्रॉनिक periodic classification of elements. Okay, and today our topic is electron affinity. Okay, so in the previous video we learned about the ionization energy and the trends along the period and below the or down the group, right? So today we will be learning about what is electron affinity and the trends across the period and down the group. And also we will be learning some special cases. Okay. Now, what is electron attract? Okay, so that's the, in common words, the meaning of affinity is to attract. Okay, so here we have the nucleus. Okay, we have the atoms. Okay, we have the atom, we have the nucleus. Okay, suppose I have an electron. Okay, and you know the nucleus is positive charge, electron is negatively charged. The nucleus will try to attract the electrons. It will try to attract the electrons towards itself, and this electron goes to the valence shell. Okay, and when this happens, some amount of energy is released. Okay, and those elements, some elements have more tendency to attract the electrons and some have less tendency. Those that have more tendency to attract the electrons release more energy. Okay, so that means electron affinity is the tendency to attract the electrons. Okay, so affinity is the tendency to attract the electrons in general term. Okay, so if I talk about the definition of electron affinity, so electron affinity I'm writing as EA as short form. Electron affinity is the energy released when an electron is added to a neutral isolated gaseous atom, neutral isolated gaseous atom, to form what? Gaseous ion. Okay, so electron affinity is the energy released. It's the energy released. When the energy is released, when the electron is added to the neutral isolated gaseous atom to form what? Gaseous ion. Neutral because when they don't have any charge, and isolated means when they are not in groups. Okay, otherwise it is difficult to add the electrons. So affinity means it's a liking for the electrons. Okay, so electron affinity is the energy released when the electron is added to the valence shell of an atom, of a neutral isolated gaseous atom, to form gaseous ion. Okay, and this word neutral isolated we discussed during the ionization energy as well, right? Now the unit of electron affinity is same like ionization energy, electron volt per atom or kilojoules per mole. Kilojoules per mole or electron volt per atom or kilojoules per mole. Okay, so this is the unit. Okay. Now, coming to the next topic, which is related to electron affinity, is electron gain enthalpy. Okay, sometimes they use the term electron gain enthalpy. Delta H e.g. electron gain enthalpy. Okay, suppose I have an atom, okay, in the gaseous state. It is attracting an electron and it is forming an anion, because there's a negative charge. So anion or an ion, negative ion, and it is releasing 8 eV, electron volt of energy is released. So this is the electron affinity. Now, electron affinity. So electron affinity I am representing by EA. Okay, so electron affinity is plus 8 electron volt. Okay, now delta Hg, electron gain enthalpy, is nothing but the heat. Okay, the magnitude of electron gain enthalpy is same as that of the electron affinity, that is 8, but the sign is negative. Okay, so this is also the heat released, okay, when the anion is formed or when the electron is attracted towards the isolated neutral gaseous atom. Okay, but the magnitude is opposite to that of electron affinity. Okay, and in this case, because it is having a negative sign, because it has a negative sign, this is exothermic. Exothermic, because this has a negative sign. So electron affinity and electron gain enthalpy, magnitude is same, but sign is different. Opposite. And electron affinity will be mostly, it will be positive. Okay, we will learn this with an example now. Okay, now, suppose if I have, if the electron affinity for any reaction, or when the electron is added to an atom, when the electron affinity is maybe plus 12 eV, electron gain enthalpy, what is the electron gain enthalpy? The magnitude will be 12. What will be the sign? It will be negative. Okay, so this is what you have to remember. Okay, now coming to an important topic, which is successive, which is very important, successive electron affinity. Okay, so suppose I have this part I'm keeping like this. Okay, now coming to successive electron affinity. Suppose I have an atom, a gaseous atom. Okay, it attracts an electron and it forms an ion. And this is electron affinity 1. Okay, and generally, this is positive, because this is a neutral gaseous atom and it is easy for the electron or for the nucleus to attract the electrons. Okay, but if I have this ion, gaseous ion, and more electrons are coming, do you think the nucleus will, or the addition of electron is easier now, or it is difficult? Obviously, it already has a negative charge, and attracting more electrons means it is a difficult task, right? So we have to give energy. Okay, so this energy, the first electron affinity, this energy, it is the energy released when the electron is added to the neutral atom. But in the next case, this is the first step. But in step 2, it's already an anion. There's already a negative charge there. Adding additional electrons is very difficult. We have to provide the energy. So this will form A2 minus, and the energy that we provide is electron affinity 2, but because we are giving this energy, it has a negative sign. Okay, so this will have a negative sign. So always EA1 is positive and EA2 is negative, always. Okay, always this is negative. So that means what about EA3? If adding electrons to anion A minus, adding electrons to this ion is so difficult. What about adding electrons in A2 minus? It will be more difficult. So definitely EA2, EA3 will be more negative, right? So step 1 is easier. Adding an electron to neutral gaseous atom is easier. Okay, so that is why EA1, that is electron affinity 1, is positive. But adding an electron to the anion is difficult. So that is why electron affinity 2 is, or the second electron affinity is negative, and it's always negative. Okay, now in the first step, electron affinity 1 is positive. So what will be, so this I'm just revising with you. Okay, so don't get confused with this. So remember one, the other one is just the opposite. For example, electron affinity 1, if it is positive, what about electron gain enthalpy? Definitely it will be negative. So that's why, if you remember electron affinity 1, what is the sign? Electron gain enthalpy will have the opposite sign. So similarly, electron affinity 2 is negative. So what will be electron gain enthalpy of this particular reaction? It will be positive. So we will be mostly talking about electron affinity. Electron gain affinity will have the opposite sign. That's it. So to avoid confusions. Okay. Now, coming to a question. So just coming to a question, if I have an atom X is gaining an electron to get an ion X minus, that is electron affinity 1. And the value is maybe 10 electron volt. Okay. This ion, negative ion, again gains an electron to give you X2 minus. So this is the next electron affinity 2. So definitely, if the first one is positive, the second one, it is difficult to add on the electron. So definitely this will have a minus value of electron affinity. So maybe 12 electron volt. So this will have a minus sign. Okay. So if I say electron affinity 1 plus electron affinity 2 is less than 1, less than 0, greater than 0, or equal to 0, what will be your answer? It will always be less than 0. Okay, so it will always be less than 0. A will be the answer, because as you can see, even if these values are not given also, always electron affinity 2 will be negative, and it is more negative because X minus is already an anion. There is already a negative charge, and adding electrons to this is very difficult. So the amount of energy provided is high. So that is why this is more negative. Okay, so always the second electron affinity is highly negative. So that is why the sum of first electron affinity and the second electron affinity will be less than 0. Okay, so it will be opposite for electron gain enthalpy. So if you remember the first, if you remember one about electron affinity, the electron gain enthalpy will be the opposite. It will be greater than, 0. Okay, so just try to remember one to avoid confusion. The electron gain in enthalpy is the opposite sign. Okay, the magnitude is the same, the sign is opposite, right? Now, coming to a next question. If I have nitrogen, it is gaining 3 electrons to give you N3 minus. Okay, now if we have this kind of a reaction, okay, and delta H Eg greater than 0, less than 0, equal to 0. Okay, and what would be your answer? Okay, here they are not talking about electron affinity, electron gain. They are talking about electron gain enthalpy. Okay, so in this case, over here, you can just write down the first one. It is gaining first 1 electron, and it will give you N minus. There will be EA1. It is gaining another electron to give you N2 minus. This EA1 is positive. EA2 will be negative. Then N2 minus will gain another electron to give you N3 minus. You get EA3, which will definitely be positive, because adding an electron to 2 minus ion is very difficult. Now, when you take a sum of this, you can cancel a lot of terms. Okay. So you have nitrogen plus 3 electrons giving you N3 minus plus. What is the sum of all these terms? The sum of all these terms will be negative. So EA total is negative. Right. If the total of all these is negative, what will be the opposite of this? This is opposite of electron affinity. I mean, not the opposite, you can say. The electron gain enthalpy has the same magnitude, but it has opposite sign. Right. So if this is positive, what will be your answer? It will be greater than 0. Okay. So for why I wrote this example, because if you see here, in case of an in this case nitrogen 3 minus, right? So this is called as a polyvalent ion. So for a polyvalent ion, you can directly say that delta HEG, that is electron gain enthalpy, is greater than 0. Okay, so polyvalent ion means showing more than one valency. Okay, for example, if I say oxygen, 2 minus, the valency is more than, it's 2 minus, right? It's not 1. If it's 1, if the valency is 1, you call it as univalent. Okay, if it is 2 or more, we can call it as polyvalent. Okay, so in this case, it is polyvalent. So for polyvalent, you can easily, so in case of polyvalent anions, electron gain enthalpy is greater than 0. Okay, because electron affinity will be less than 0. Okay, so just remember either in terms of electron affinity or electron gain enthalpy. Okay, because for both of them, the magnitude is the same, the sign is different. Okay, so let's take one more example of a polyvalent ion. For example, oxygen. Oxygen. Okay, so oxygen is gaining 1 electron to give you O minus, and you have electron affinity 1. That will definitely be positive. Then you have oxygen minus plus electron giving you O2 minus, where you have electron affinity 2. And this is definitely negative. Okay, so if I compare EA1 and EA2 in terms of magnitude, okay, magnitude. Sign, you know, both where EA1 is positive, EA2 is negative. In terms of magnitude, I told you a lot of energy is needed for the electron to be added to O minus, because O minus is already negatively charged. So EA2 will be greater than EA1. Okay, so definitely the total will be, so if I say EA1 plus EA2, the total will be less than 0. So now it's easy. If I ask you to find out the electron gain enthalpy, that will be greater than 0. Right? So just remember, either in terms of electron gain enthalpy, either in terms of electron gain enthalpy, the electron affinity will be equal in magnitude but opposite in sign. Okay, so either way. So coming next to factors affecting the electron affinity. Okay, factors affecting electron affinity. So this part I just have. This is our topic. So factors that affect electron affinity. Okay, first one is size. Okay, suppose if I have an atom with smaller size, I have an atom with a bigger size. Electron is coming, here electron is coming. It will be easy for the nucleus of the atom A to attract the incoming electron. But in case of B, the atom is very big. The electron is very far away from the nucleus. So here it will be, electron affinity will be less, because nucleus cannot attract the electrons that much as compared to that of A. So we can say electron affinity is inversely proportional to the size. Okay, so this was the same case for ionization energy too, right? So coming to the next one, next factor is nuclear charge, effective nuclear charge or nuclear charge. We can call it as Z also. Okay, suppose I have an atom where I have 2 protons. I have another atom where I have 5 protons. Atom A, atom B. Here incoming electron, here incoming electron. In case of B, there are more protons. The nuclear charge is more. So it will attract the incoming electron more readily than in case of A. So this same case we saw for ionization energy too, right? So electrons are more attracted by B than A. So more energy is released by B. So here more energy released. Electron affinity is the energy released, right? So more energy is released. So we say electron affinity is directly proportional to Z. The same case we saw for ionization energy too, right? So I hope till here it is clear and you know this, right? The same case we saw for ionization energy too. Coming to the next one, which is called as electronic configuration, which is very important. Third factor is configuration, electronic configuration of electron or electronic configuration. Now, if I have stable configurations like half-filled or fully filled. What are the half-filled and fully filled configurations? Half-filled is P3, D5, and F7. These are the half-filled. Fully filled is P6, D10, and F14. Now, these half-filled and fully filled configurations, they are already stable. They don't need electrons. Okay, so for them, they don't have affinity for the electron. Okay, electron affinity or the liking for the electron is more when they are deficient of electron or they are not fully filled or don't have a stable configuration. Okay, so in this case, the electron affinity will be almost zero because they are already stable. They are already stable. They don't need the electrons now. Okay, so they are almost zero or very, 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 very less. Very less. Okay, so this is also an important factor that you must remember. Okay, now coming to trends along the period and down the group. Coming to trends. For trends, we study along the period. First is along the period. From left to right, right? From left to right. Now, along the period, the general trend you know. Along the period, from left to right, what is happening to the charge? Charge is increasing, the nuclear charge. When charge increases, what is happening? The tendency to attract the electrons increases. Attract the electrons also increases. So more energy is released. So what is happening? Electron affinity increases. Okay, and more energy is released. So from left to right, what is happening to the electron affinity? Increases. Why? Because the nuclear charge is increasing. If nuclear charge increases, what is happening? They will attract the incoming electrons more. So more energy is released. So electron affinity increases. Same we saw for ionization energy also. That also increases, right? The explanation is the same. Okay. Special cases we will be learning. First, we will learn down the group. Okay. Now, second trend is down the group. This also you will be able to say down the group. What is happening to the size? Size is increasing as the number of shells increases. So what happens? The nucleus is far away from the incoming electrons, right? So the nucleus will not be able to attract the electrons more. So as you're coming down, what happens to the force which the nucleus attracts the electrons is less. So electron affinity, the energy released is reduced. So electron affinity decreases when down the group. Same way we saw, ionization energy also decreases down the group. Right? So same as ionization energy. So along the period, electron affinity increases because of the increase in the nuclear charge. Down the group, electron affinity decreases. Why? Because of the increase in size. And we also saw electron affinity is inversely proportional to size. Hope this is clear. Now, coming to some special cases and also some examples of some groups and periods. Suppose we have period 2. Okay, period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And the atomic number is 3, 4, 5, 6, 7, 8, 9, and 10. Now you have to, these are the elements from period 2. Arrange the elements in order of electron affinity, increasing or decreasing, whatever. Okay, anyway, you can. So, according to what we learned just now, what is your expected? So, this is the question, okay? So, according to what we just learned, this is the period. So, from left to right, what is happening to the electron affinity? Increasing because the nuclear charge is increasing. So, what is your expected arrangement? Your expected arrangement will be what? Lithium is, so it is increasing. So lithium will be less than beryllium, less than boron, less than carbon, less than nitrogen, less than oxygen, less than fluorine, and less than neon. So this is the expected. Okay, this is your expected. But in this case, you must remember few things must be taken into consideration. Here, neon is the noble gas. It has fully filled shells, noble gas. It has a stable configuration also. So that means neon has the lowest electron affinity, right? Now, this is the expected. Okay, now, let's look for other discrepancies. For example, if I write down the configuration, this is 1s2, 2s1. I'm just writing down this is 1s2, 2s2. This is 2p1. This is 2p2, 2p3, 2p4, 2p5, and 2p6. Now, over here, you can see beryllium has fully filled S subshell. Nitrogen has a half-filled subshell, right? So these two elements also we have to consider. Also the noble gas, neon, which already has a stable configuration. So in reality, taking these factors into consideration, what will be our order? Neon will have the least electron affinity. It is almost zero, very, very less. It doesn't need any, because you know that noble gases are unreactive. They're already stable. So neon will have the least electron affinity. That will be less than, we have two more factors, nitrogen and beryllium. So next one will be nitrogen because it is half filled. Then we have beryllium because of the S subshell, which is fully filled. Then we have the normal order, lithium, boron, carbon, oxygen, and fluorine. So this is the real order. Why? Because neon is fully filled, it has a stable configuration. Beryllium also has a stable configuration because it has fully filled S subshell. Nitrogen is half filled. So whenever an order is asked, you have to take these informations into consideration. Okay, now, again, one more small information over here. If you see, if you compare lithium and boron, okay, so lithium is 1s2, 2s1, and boron is 1s2, 2s2, 2p1. This is the configuration. Now, if you compare lithium and boron, okay, in these two cases, who will readily accept the electron? If you see here, lithium is short of one electron for lithium to become 1s2 configuration. If it achieves 1s2, it is achieving a stable configuration. But in case of boron, if 2p gets one more electron, it will become 2p2. It is neither half filled nor fully filled. So it cannot be considered as a stable configuration, right? So here, in this case, lithium, comparing lithium and boron, lithium will more readily accept the electrons because after accepting the electron, it tries to become stable. Every element tries to become stable. So keeping this in view, okay, our configuration or our order is like this. Neon is very less because of it is fully filled, stable configuration. Then we have nitrogen, half filled subshell. Then I have beryllium. And comparing lithium and boron, who will have more tendency to accept the electron? Who will readily accept the electron? Lithium, right? So next is boron, okay, because it will less readily accept compared to lithium. Okay, so lithium will be having higher electron affinity than boron. Lithium would like to take electron more faster than boron. Okay, so it will be higher than boron. Then the normal order, carbon, oxygen, and fluorine. Okay, so if a question is asked comparing lithium and boron, lithium will readily accept electron. Why? So that it is achieving, so that its 2s orbitals are fully fulfilled to achieve the fulfilled 2s orbital configuration. Okay. Again, if a question is asked, so every atom tries to become stable. Okay. So in this case, lithium, if it gains one more electron, it will become stable. Okay. So that is why it is having more electron affinity than boron. Now, if you are asked to compare which is more stable, lithium minus or boron minus stability, which is more stable? Sorry about the spelling, stable. Which is more stable? Lithium ion or boron minus ion? Okay, lithium ion, okay, it has one more negative charge. So 1s2, 2s2. In boron minus, it is 1s2, 2s2, 2p2. Please remember, students, I'm writing down the configuration of the ion, not the atom. Okay, ion. This is boron minus ion. This one. Now, in this case, lithium, will it accept any electron? Lithium ion is already fully filled. There's no space for any electron to come in. So it's fully filled. So it is already stable. right? Lithium is more stable. B minus is less stable. Okay, and which one will readily lose electron? Which one will readily lose electron? So lithium ion is stable. If lithium ion is stable, will it lose electron? No. Who will lose electron? B minus, because it can lose electron. B, because it's not stable configuration. Okay, so B minus will readily lose electron because L minus, lithium ion, is already very stable. It will not like to lose that stable condition. It will not lose electron, but B minus will readily lose electron. Okay, so these kinds of questions are very common in competitive exam. Okay, so I hope this is clear. I hope you understood why we wrote the order, okay, and lithium and boron, about lithium and boron. Okay, okay, students. Coming to another special case. Okay, if I'm taking group 17, okay, group 17 is very important. Many questions come from group 17. If I have fluorine, chlorine, bromine, iodine, okay. So the normal explanation, coming down the group, what is happening to the size? Size is increasing, electron affinity decreases down the group, right? So what is the expected order? So the expected order is fluorine, electron affinity is more than chlorine, more than bromine, more than iodine. Okay, but it is seen that in reality, chlorine has a higher electron affinity than fluorine, than the normal order. Okay, this is because fluorine is a very small atom compared to chlorine. Fluorine is very small and chlorine is bigger compared to fluorine. Okay, so if the electron comes in also, already there are electrons in fluorine, right? The tendency of electron repulsion increases because of the small size of the atom. Small size of atom. But in case of chlorine, because chlorine is bigger, they have enough space. The chances of electron repulsion is very less. So that is why chlorine has more electron affinity than fluorine. Okay, so of course, nucleus will attract, in case of fluorine, the nucleus will attract the electron, but here the chances of electron repulsion is very high because of the small size of fluorine. Which atom? Fluorine atom. But in case of chlorine, no such problem arises. So that is why chlorine has higher electron affinity compared to fluorine, and then the normal order. Okay, so I hope this is clear. So you can write down the explanation like this. Here the configuration is 1s2, 2s2, 2p, 5. Right. Here 1s2, 2s2, 2p6, 3s2. This is 17. 17. So here the last electron is coming to 2p. Here the last electron is coming to 3p. So you can write down the explanation. Fluorine has a smaller size. The incoming electron goes to which shell? Goes to 2p subshell. Okay, and I mean the 2p subshell is nothing but the second shell, right? So the second shell. So, and the electron experiences a lot of repulsion. So the EA is lesser. Electron affinity is less. But in case of chlorine, the incoming electron goes where? Incoming electron goes to the third shell, goes to third shell, which is 3p subshell. Okay, so that is why, and the repulsion chances are very less as compared to fluorine. Okay, so I hope this is clear. Now coming to another question. If I ask you which ion is more stable, which is more stable, okay? Okay, we talked about the small size of fluorine, okay? And forming fluorine minus is itself difficult because of the small size, and there is more chances of electron-electron repulsion. Okay, so fluorine minus formation itself is very difficult. But in case of chlorine, the size is big, so the chances of electron-electron repulsion is very, very less. So chlorine minus is more stable than fluorine minus, F minus. Okay, so chloride ion is more stable than fluoride ion. Okay. Now, students, coming to the other groups like group 14, group 15, and group 16. Okay, I have here carbon, silicon, germanium, tin, and lead. Group 15, I have nitrogen, phosphorus, argon, tin, bismuth. Okay, group 16, I have oxygen, sulfur, so oxygen, okay, sulfur, selenium, tellurium, and polonium. Polonium is radioactive, so I won't include in the order, just I've written it, okay? I'll just write group 17 too, so that it's easy to compare. Fluorine, chlorine, bromine, iodine, okay? Now, group 14, 15, and 16 follow the same trend as group 17, okay? So, group 14, in group 14, silicon has a higher electron affinity than carbon. In group 15, phosphorus has a higher electron affinity than nitrogen. Okay, by mistake I'm writing oxygen, sorry. Then similarly, here, group 16, sulfur has a higher electron affinity than oxygen. Okay, so group 14, 15, and 16 follow the same trend. Okay, there's one more discrepancy. I'll just tell you first. I'll just tell you, but before that, in case of group 14, we write the order like this. Silicon is having a higher electron affinity than carbon, then the normal trend, germanium, tin, and then lead. Similarly, for group 15, I have phosphorus greater than nitrogen, argon, antimony, and bismuth. This is antimony. Then the discrepancy that I was talking about is that oxygen has lowest electron affinity. Oxygen has lowest electron affinity. So I write group 16 as sulfur greater than selenium, tellurium, polonium I'm not including because it is radioactive. Least is oxygen because of the lowest size, smallest size, and the chances of electron-electron repulsion. Okay, so that's why I wrote group 17 also here, so that it's easy for the comparison purpose. So just remember one group, and the other group 14, 15, and 16 follow the same trend, except for group 16, in which oxygen has the least. Okay, in case they are mixing up two groups, for example, if I say arrange oxygen, sulfur, chlorine, and iodine in an order of electron affinity. Now here, this is group 16 and group 17, right? Group 16 and 17, they have mixed. Now students, please remember, so I'll just segregate group 16 and 17. Oxygen, sulfur, chlorine, iodine, right? Always, all the elements of group 17 has more electron affinity, even fluorine, everybody. Group 17 has more electron affinity than, I'm comparing, than group 16. Okay, so over here, all the members of group 17 will have higher electron affinity compared to any other group. Okay, so first we will do the groups individually and then combine them. Group 16, oxygen or sulfur, who will have higher electron affinity? Sulfur. Sulfur is greater than oxygen. In this case, chlorine will have higher electron affinity than iodine. Now I mix up and I said group 17 has higher electron affinity compared to other groups. So I write first chlorine greater than iodine, greater than sulfur, is greater than oxygen. Okay, so similarly, if I say arrange the following elements in order of electron affinity: oxygen, sulfur, chlorine, and bromine. So this is group 16. This is group 17. So here, in this case, what is the order for group 17? Chlorine is greater than bromine. In this case, sulfur is greater than oxygen. Now, I said group 17 has a higher electron affinity compared to all other groups. So chlorine greater than bromine is greater than sulfur is greater than oxygen. Okay, so students, these are some few information about electron affinity. Okay, so more about this, we will be, more questions we will be doing when we do the past paper questions. Okay, so that's all for today. Thank you. Have a great day.